Space blockbusters are Hollywood's go-to for high-stake investment. They cost a metric ton of money to produce, but might also return a truckload of money. Gravity of 2013 is one such blockbuster that paid out big time, grossing more than $700 million at the box office. The film did well in the critical department, carried by the powerful performances from leads Sandra Bullock and George Clooney, playing two astronauts stranded in orbit with nothing to rely on but each other. The effort by the writers to maintain fidelity with the underlying science was also very evident. The dialogues have been verified by real astronauts to accurately resemble the lingo they use on the missions. However, a few major plot points do stray from what is scientifically plausible, if we disregard the suspension of disbelief, so we'll be looking into them today. In the first act of the film, astronauts aboard the Space Shuttle Explorer are conducting maintenance on the Hubble Space Telescope, when a debris field collides with them, killing everybody except Stone and Kowalski. With the shuttle destroyed, the stranded astronauts decide to travel to the International Space Station, or ISS, for shelter. While the journey is depicted as being long and treacherous, in reality it is simply impossible due to the one physical property that's keeping them in orbit: velocity. To achieve orbit and never fall back down to Earth, a spaceship has to shed 3/4 of its weight in fuel in order to reach more than 7,200 meters per second. This way, when gravity pulls it down, the spacecraft will have traveled far enough to miss the ground as it curves away. But the space shuttle and the ISS are each traveling in different directions, which result in massively different inclinations of their orbit. In order to reach the ISS's plane of orbit, the astronauts must match their velocity vector to that of the station. Now, good news, the math is very simple because of trigonometry. Bad news, the fuel needed is far beyond what a spacesuit can carry, so they aren't going to make it there, even with noble sacrifices. Speaking of Kowalski's sacrifice, this dramatic scene happens to be the most nitpicked one from the film. As they arrive at the ISS, the station is heavily damaged by the same debris field. With Stone's tether to the space station breaking apart, Kowalski disconnects his own tether to her and floats away to his certain death. Now, if they were tethered behind on a car, with winds rushing over their ears, it would be reasonable to fear that their lines might break. But in space, nothing's making them accelerate nor decelerate, and it is apparent that their net forces are in equilibrium. As Newton's third law dictates, if Kowalski simply tugged on his tether, the reaction to that tension would easily bring him back near the station. Now, there does exist an explanation that perhaps they are rotating and subject to an outwards centrifugal force, but it is simply unnecessary to consider such a small inaccuracy when it is in service of the film's message.